Welcome to the Loughborough University's Institute of Advanced Studies. I'm Professor Ksenia Chmutna. I'm the director of the IIS, and it's really wonderful to have so many people in the room today. And also for those of you online, thank you for joining us. It's a hybrid event as always, so for those of you online, if you have any questions, please post your questions. We will be monitoring the chat. For those of you in the room, you will have a lot of opportunities to talk to our fellow today. It's our absolute pleasure to host Giulia Borriello today at the IIS. IIS is a place where we discuss the most exciting things that are happening at the university in terms of research, the most creative ideas, the most important topics. And I think today the conversation about academic achievement is something that we're all hoping to know more about. So thank you so much for being with us, Giulia. And I would you like to introduce Giulia? Yes. I think you're okay with that owl, right? Yeah, okay. Yeah, so please.
Oh, yeah. So I'm pleased to introduce Giulia, who's visiting us for a week from Kent State University, where she's conducting research broadly looking into the predictors of early maths understanding. Prior to this, she was a postdoc for 4 years in Emily Frye's lab in Indiana, where she conducted lots of research into patterning and early maths. And prior to that, she was a postdoc for 1 year at David Purported's lab at Taylor University. So over to Giulia.
Thank you. Thank you guys so much for coming. I'm super excited to be here. This is a really beautiful space, and thank you, for listening. So today I am going to be speaking with you about some really exciting work that we are in the process of trying to get published. It's been 2 years. We are waiting. This is the second round of reviews, and we are just sitting tight and hoping to see where we land. But this is going to be a talk about a meta-analysis of the associations between patterning and academic achievement. So I'm super excited about this because it is, assuming I can click.
Oh, sorry, let me try again.
There we go. Because it's my first meta-analysis that I've done, and it's been really neat to see how that is a really useful tool for sort of understanding a whole topic in the literature and getting a sense of when things have been done, how they've been done, and sort of how to think about things critically from a really pulled out viewpoint. Okay, so why are we doing this and why do we care? One of the big goals of psychology is to really try to understand and pinpoint critical skills that serve as indicators or predictors of academic achievement and academic achievement trajectories, and to understand how we can shape those skills over time. So what things really might predict achievement? There are lots of things that people have looked at. So there's certainly work looking at very early academic skills and how those might sort of help funnel people into different levels of achievement. There's focus on specific skills like working memory or inhibition, general intelligence, also work looking at genetics and whether genetic pathways predict achievement and in relation to environmental ones, SES, all sorts of things. But what we're going to focus on today is a question that is open and really hasn't been asked before. And certainly no meta-analyses have ever been done that have looked at this, as far as we know. And that is patterning. So, important first question, and I do apologize for some of you that already heard some of this yesterday, but what is patterning? Okay, we are defining, and this is really critical, the definition and how we're talking about this and thinking about it to the way that we did the work in the coding for the meta-analysis. We define patterning as the ability to detect systematic regularities in a predictable series of elements, and those elements will vary along a number of different dimensions, and not just one. So things like the shape of the elements, objects, that you can use sounds or letters or numbers. So for an example, in this very top right-hand corner here, what you can see is a repeating pattern, and it varies in two ways. It varies by the shape of the objects. It also varies in terms of the size of those objects. And both of those elements sort of work together to create a distinct structure that underlies that whole pattern. Okay, so I've defined it, but why do we care about it? Well, the reason we care is that there's lots of correlational work out there and a little bit of intervention work that suggests that patterning is really a critical correlate, especially of early math knowledge, and particularly math, it seems, is like the big area that everybody is focusing on. How does patterning and early patterning relate to math skills? So there's work suggesting that there's concurrent links and longitudinal links between patterning and math. The issue, however, is that there's most of this work has really largely been done in the last maybe 10 to 20 years. There is some stuff from before, but if you look across those different studies, there's inconsistencies. So some find no relations, some find positive significant relations, and there's quite a bit of variability from study to study. Like I said, there's this really heavy focus specifically on achievement in math. There's a few papers in reading, not very many at all. And perhaps most importantly of all, is that not every study accounts for important potential covariates of other cognitive skills. Some studies might, some might focus on one or two, others focus on different ones. So it's really unclear. And I think the big question that I'm sure somebody today is going to ask me is like, you defined it, but really, what is it? What is this thing? And is it just intelligence or something like that? And you're telling us nothing new, which is a good and important question. So for all of these issues, a meta-analysis is a pretty good way to try to get at and start picking this apart and understanding it better. So in this present study, what we are going to do is ask this question for the first time across the whole data, across the whole literature with any data set that we can find that has measures of patterning and math or reading achievement and cognitive variables. Do we really see patterning as a significant predictor of academic achievement? And can we get a better sense of the overall estimate of that? So strength and magnitude and direction of these relations. We're going to do this both looking at concurrent relations and links, as well as longitudinal links. What can we see from both types of data? And we're going to do this in math achievement and reading achievement. So in these two domains that are thought to be kind of the most traditionally important domains of achievement, if you look across cultures, different countries, these are the big ones that people are really focused on. So we figured we'll start here. And perhaps biggest of all, what we really wanted to do was not just say what are the links between patterning and math or patterning and reading, but after we account for a whole array of specific cognitive abilities, whatever we can find that people have done, do these links really truly still hold? Is patterning truly a unique predictor, or is it not really that different from other things that we already know? And we're just, cycling through old questions here, but calling it something different. Finally, we're going to look at a number of potential moderator variables to see, are there ways that these links from patterning to math or patterning to reading might vary depending on important other variables. So I'm going to briefly walk you through and try not to waste too much time on these specific moderators. But first, we're going to look at some moderators specific to patterning measures. So we're going to look at patterning type and pattern task. Next, we're going to look at moderators specific to math achievement. So we're going to focus on different types of math topics and math knowledge. We'll do the same for reading with different types of topics in reading. We're going to look at specific cognitive abilities. And finally, we're going to look at age and whether age is an important continuous moderator. Okay. Again, apologies for yesterday, but let's talk a brief moment about the different types. So there are certainly more than just these two types of patterns that people consider to be basic pattern types. But these are kind of the biggest ones that pop up over and over in the literature, especially with work on little kids. So repeating patterns are patterns that have a core unit, and that unit continues in a predictable way over time. So it systematically can continue and extend forever. And really the key thing and what makes a pattern, according to our definition, and what we think is that what you can do when you look at something that has multiple units that repeat in order to say that you are a good pattern understander, you're a pattern knower, is to be able to pull out that core structure. And some little kids really struggle in that, to be able to say, yeah, I see this pattern, it's an AAB pattern, it's a little big pattern, or it's a ABA pattern, it's a circle, square, circle pattern, right? Being able to kind of identify that abstract thing that's underlying this pattern and just say, the thing about this pattern that makes it what it is that it's just a 1, 1, 2, right? So saying something really abstract like that, not all little kids can do. And that's what's so neat, is that kids who can do that tend to be better at math. So we focus on repeating patterns. Much of the literature, especially in the last 2 decades, has focused on this, especially with little kids between the ages of 4 to 6. And we know that these skills develop quite rapidly during this period. The next thing is growing patterns. Growing patterns are something like you see here, where one of the things is increasing in a systematic way. It could increase, it could also decrease. So you could think of a pattern that maybe goes something like this, and but in the way that it's doing that is systematic. So it might look like this, especially for a little kid. It could also look something like this, or something much harder with much larger numbers. And you might have to extend the pattern, or a hard question could be something like, okay, 99 places from this one, what would the number be? I can't do it. Maybe one of you here can. So growing patterns, unsurprisingly, then tend to be more challenging. And there's data to support that their kids do worse, and adults, on those than repeating patterns. And as a result, there tends to be more work focusing on growing patterns in middle childhood and beyond into adulthood. So these are our big categories. What we looked at was repeating patterns, growing patterns, and then some combination or kind of others as well. So some measures include both, or they have symmetric patterns, other types. But this was our focus. The next thing is the type of pattern task. So we categorize pattern task in 3 ways: either simple pattern tasks or activities, complex ones, or some combination. Combination would be either comprehensive, or it might include some sort of one-off special thing that is less frequent. So for your simple tasks, you can think about pattern duplication is perhaps the most simple, right? So I show you a pattern, I want you to either recreate that pattern or click on the one that matches it exactly. Pretty easy. An extension, where you have to see a pattern and you have to extend it by 1 full unit. So which one of these would continue this pattern? Fill in the missing, or interpolate, where you have to pick a piece that would complete the pattern somewhere, not at the end, but in the middle somewhere. So those are your more simple ones. The more complex ones, they're thought to be more simple because you can do some sort of visual match, one-to-one matching, right? You might not necessarily have to understand, hey, this is a 2-2 pattern. I can just say, well, green, 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 blue, green, or something like that. Oh. Okay, I think there might be feedback, but maybe it stopped. For the complex patterns, what you have to do is really understand more of this higher level abstract relation between the pieces. And it might be only between 2 pieces, or it could be between multiple pieces. So for this one over here, what you have to do is see a pattern and actually isolate or identify the core unit. So what is the thing that makes this a pattern? So being able to do that is actually quite hard for little kids. The other thing is abstraction, where you see a pattern and you have to recreate that pattern using novel pieces. So for this, it's really looking beyond the visual or perceptual features of that pattern and being able to, again, pull out and say, actually, this is a 1-2-1 pattern, and I just have to match and find a 1-2-1 pattern here. So those are our categories for that. For math moderators, we looked at 2 things. We looked at the topic of math, the domain, and the type of math knowledge. So for topic, lots of people have really focused on numeracy, the more basic or foundational skills, and how patterning might link to that. If you think about something like a growing pattern could be something as simple as 1, 2, 3, 4, 5, or 1, 2, 3, right? If a little kid gets that, maybe they're going to understand something like 21, 22, 23, 101, 102, 103. So is there something about getting that, detecting that helps you to just become more automatic, get those underlying principles and rules of math. So that's numeracy. Another option is calculation, where you're more operating on the math and having to go beyond your more fundamental thing. Now I'm going to use the rules and things I know to help me to calculate. And no, it could be something as well as like adding 10 is always going to give me in +1 or +10 is going to look sort of similar, right? There's also more advanced types, and we were really interested in, this was maybe one of the things we were most excited about, picking these apart and especially focusing on some harder things like fraction knowledge or algebra or geometry knowledge. People have really thought in more of the math ed world that there might be some sort of functional reasoning that kids do that would help them take pattern knowledge and use that to do things like algebra, geometry. But we just don't know that much because there's not nearly as much work out there. However, I'm probably going to say this a few times across this talk. There are some constraints with how many things we could possibly look at. We have to think about the data. So we had to do some condensing here. So we've got our 3 topics. You have to make some hard choices as a scientist, I guess. That's as critical as it gets for me. Then for math knowledge, it's thinking about things like procedural or conceptual knowledge, or some combination. So procedural knowledge is more about strategy. So if a little kid is counting and learning how to do simple addition, they might count on their fingers, they might think in their head, or they might just know the answer because they've done it so many times it's automatic. So having different strategies. Conceptual knowledge is more about those rules and principles that govern math. So knowing that if I add 0 to any number, I get the same number, and then some combination. So we basically, we coded for any of the measures that were used in any study, which of these would it fall under? That was more annoying than we expected it to be, but what can you do? Next for reading, we looked at different types of reading topics. So decoding knowledge, comprehension knowledge, or some combination thereof. Decoding is more about understanding links between the sounds of words and the way a word looks or its symbols. Comprehension is understanding that text, right? So the first one is thought to come on earlier, and you have to really get good at making those phonological skills strong to then go on and have your good comprehension skills later. Finally, we looked at a number of cognitive abilities. We looked specifically at working memory, other types of executive function skills, spatial skills, analogical reasoning or nonverbal reasoning. So here you'd have things like your matrix reasoning, tasks, and then finally verbal reasoning, a knowledge of language or vocabulary. Then the last moderator we had was age. And what we really wanted to know here was, if we look at all of the literature that's out there, do we see that the relations between patterning and math or reading vary over time? So might they be stronger in early childhood, or might they be stronger in later on in adulthood? And we had 2 theories that really grounded our thinking about this. The first is known as the investment theory, and this investment theory is an older theory that really falls on some of the general intelligence literature, and it suggests that we would see stronger links between patterning and achievement earlier in life. So in early childhood, when kids really have less familiarity with academic experiences and when they're engaging with academic tasks and it feels more novel. So something about having these patterning skills helping to ground your very early kind of experiences and engagement with academics. Then there's the mutualism theory, which suggests the opposite. It suggests that as you get older, your academic skills and your patterning skills advance. They get more complex and they actually build on one another in this mutual way back and forth. So over time, the strength between those skills should increase. Okay, so to be honest, first meta-analysis, we didn't really know too much. We had some hunches. So really much of this is quite exploratory for these moderators, right? We certainly expected that we were going to see significant links between patterning and math and probably patterning and reading. We really thought our money was going to be on this strong, nice, decent sized link between patterning and math. For our moderators, we're thinking that probably younger is where you're going to see the most bang for your buck, right? It's these, most of the tasks, especially recently, look at these early, really basic patterning skills. So we were really excited to look into that because there's less data, but there is some out there looking at adults. That's our hunch. We really thought numeracy, these early foundational skills, probably is going to be the strongest link, but we really don't know. And it's an open question. Reading, we truly have no idea. We wouldn't even want to say. And cognitive skills, again, we have some thoughts, quite open. Okay, so what did we do? This is our Prisma chart, and it shows you how we went from the 16,000 plus hits that we had and whittled that down to 71 studies. I'll give you some big takeaways here. You basically have to, what we wanted to make sure we had was any data sets that had measures of patterning according to the definition that we made. And then a secondary variable that was either math, reading, or cognitive skills. So we needed both of those things, at least one of each for that secondary thing. There couldn't be any training studies that were used. So we weren't trying to see any experience they had in the study with patterning. We wouldn't have counted that. If there was like a pretest measure though, we would use maybe that first day set if we could get it. And all of that led us to 71. I know I talked about this briefly, but here are just some examples of what some of these actually look like. So some of them on the top here, you can see actually use physical pieces. So asking kids or adults, okay, here's my pattern. I want you to make one just like it. And then explaining to me how these are similar. What about your pattern is like mine? Or using little teddy bears and asking the kid, hey, can you keep this one going for me? I need your help to keep going. There's also ones that are numerical or alphabetic, so you can get some variability in terms of what sort of dimensions you use for the patterns. And as you can imagine, that's going to be a lot harder for a 4 or 5-year-old than a 24-year-old. And a lot of the patterns that are actually out there really tend to be more computerized or something, where they're kind of click which one of these on the right fills that in. Okay. So we wanted to answer these questions, and I'm going to kind of get you going here through our results. So first, we'll talk about the studies. So we had these 71 articles, 62 of those were published, and they include data from over 16,000 people from 13 different countries, a lot of them in the US and Europe. For age, 69 of those samples included children. Most of those kids were between ages 5 and 9. There were actually 13 samples that we found with adults, and most of them were university students, although we had 2 that included middle-aged or older adults, which is kind of neat. So, okay, just to ground you a little bit, we're going to start with our concurrent results, right? We're going to look at concurrent links between patterning and math or reading, and then at the end, we'll talk about briefly our longitudinal findings. Okay, so first, what we see, this is just a table that sort of tells you with the more traditional approach using meta-analytic techniques, what are our overall effects if we look at just the link between patterning and any of these things. So for patterning to math, we see a strong, moderate to strong link between patterning and math, which is pretty nice and not too surprising, what we expected. For reading, we see a weaker but significant link from patterning to reading. So across all our papers, here's what we're finding after taking all those estimates. For cognition, we see small to moderate links between each of the different categories that we coded for. So all of these are significant links from patterning to working memory, EF, spatial, analogical, and verbal. And this guy right here is kind of interesting, right? Kind of a nice, stronger link there compared to some of the others. Okay, so now we're going to kind of go through some of these moderation analyses. So we're going to start here with math, and remember we had a strong link from patterning to math. So what we have here is all of the different moderating topics that we included that were relevant to math. And what you can see is that age is a significant moderating variable, and the link between patterning and math is stronger in younger children or in younger individuals than older individuals, as we expected. The other thing that we found was kind of weird and exciting to us was that actually calculation skills were more strongly linked to patterning than numeracy skills. And then finally, we found that for pattern tasks, having a combination of both easy and harder tasks the link to patterning was stronger for math than when you only use easier or simple activities. So we do the same thing now for reading. And the big takeaway here is there's way fewer studies looking at reading, not a lot at all. I think we had like 31 effects that we found, and not nearly that many papers. Some of those had multiple measures. So for this, the one really big takeaway that you could consider safe here is age. So once again, we see that reading to pattern to reading links are stronger in younger individuals than older. Okay. So those were the more kind of simple models that we ran using a more simple method. But now, especially after thinking about what are the best ways to do these and tackling some great reviewers out there, we switched to MESAM, which MESAM is really the most comprehensive, sort of nicest way that you can possibly be doing thinking about all of these big questions together. So remember, what we really wanted to know was not just is patterning linked to math or is patterning linked to reading, but after you control for a whole bunch of cognitive skills that we know are going to be related to math and to reading, and probably are going to be related to patterning, do we still see these unique effects between patterning in either of these domains? And the answer to that is yes. So if you look, another caveat, data caveat here, we have two models. Why do we have two models? Because there were no studies that had measures of both verbal reasoning, and analogical or nonverbal reasoning. So it was impossible for us to have one beautiful picture to show with our reading and our math here and every single type. So unfortunately, bear with me in helping you out here. So for the model where we have verbal reasoning and all the other types of cognitive abilities included, what you see is a significant but smallish link from patterning to math. So compare that to the 0.4 that we saw earlier. It's decreased in size, but it's still there. There's a positive link after controlling for all of these other things. For reading, we see the same thing. From patterning to reading, it's small, but it's significant and it's still there. Now we're going to look the same exact thing. Instead of verbal reasoning, we've got our analogical reasoning. And what we see is patterning to math is 0.19. So it's smaller, but it's significant. It's still there. Patterning to reading, 0.12. Same thing. So big picture, patterning is a unique predictor of each. Okay, that wasn't enough. We should do it another way to just confirm. Are we sure? We've done it with the traditional way. We've done it with MESAM, using some SEM stuff related to meta-analyses. But they asked for another, so we did it. Incremental validity analyses, where we basically, in our first step, put in all of those cognitive things that we think are important to both patterning and to achievement domains. And in that second step, we add in patterning. And again, we have to have two models because one model has just for verbal and one model just for analogical. And you see the same thing. Over and above all of our cognitive abilities that we include here, the effect of patterning on math achievement in both of our models is 0.22 or 0.25. So it's significant and it's predicting math. And for reading, again, you see the same sort of trend, right? It's smaller, but those numbers are quite similar to how they just looked in that MESAM model. So we're feeling pretty good that based on all the data that are out there at this point, there's probably a little bit more now, but nonetheless, we're finding some data to support to support all of these things and triangulate to our answer. Okay. So we got through all of that, and now we are going to do one last thing, which is look at longitudinal associations. Some of you might wonder, did you look at moderators for that? And the answer is no, because there is so little data that was really just not interpretable. But what we were able to do was use MESA and ask the same sort of question. So if we're looking at the link from patterning to math, what we did was we said, how does patterning predict math achievement after controlling for patterning skills at that same time point that patterning was measured? And what we see is a small but positive link from patterning at time 1, whatever that may be, to patterning at time 2. So over time, we're seeing that these skills do in fact predict later math achievement. And we see the same exact thing for reading. Controlling for reading or prior reading achievement, patterning at time 1 is predictive of reading achievement at time 2. Pretty neat. So what does this all kind of say? How can we wrap all of this up? Well, what we found is that there is a moderate positive effect between patterning and math. That seems to be particularly strong for younger individuals, children, compared to older individuals. We found that calculation, or the ability to sort of operate on numbers, really seems to be critical. Patterning really seems to be critical for that. So you've got stronger links when you're doing calculation versus numeracy. We didn't really see anything for those more advanced skills, but part of the problem is just the amount of data that we have. There's really not very much out there that looks at that. So open questions for the future. And then we saw the type of task matters as well. So pattern to math links are stronger. This is all for concurrent when you are using a combination of easy and harder tasks than when you're only using those easy tasks. For reading, what we see is a small positive effect of reading that varies by age, with stronger links for younger people than for older people, and no effective topic. The biggest thing of all, perhaps, though, is that these links really hold even after accounting for cognition. After we look at all of the specific cognitive abilities that make people really kind of question whether patterning really is patterning, and that it might just be intelligence or nonverbal reasoning or something like that, we controlled for whatever we could possibly find that was out there, and we still see that there's links not just to math, but also to reading. The last thing that we did, which I haven't mentioned, is we compared overall effects. So what we wanted to know was, okay, people really focus on patterning to math, and they think patterning is like this really important thing specifically for math. But there's actually no data to suggest that is true or not. And we wanted to be able to ask that question. We had all this data, and we were able to essentially compare the effect of pattern to math to the effect of pattern to reading. Unsurprisingly, we found that that really is supported by the data. If you look at the overall effect of math, it is larger than the overall effect of patterning to reading, which is also pretty neat. So there seems to be something quite critical about patterning that really helps us to think about math and the different rules and things that govern math. This sort of makes sense because if you think about math and reading, one thing that is argued is just that math kind of includes lots of different rules and principles, and you have to really use those principles, and they might really change over time and get more advanced as you work on gaining different sorts of math knowledge and topics. So perhaps all of that requirement, all of that underlying capacity and need to really understand those rules might make and help that link to patterning math be so strong. Although I should say that's not proven. I'm speculating, right? That's what we think. But again, open question. And that really is the big question. So not just like, what does this mean, but why is this happening? What makes this so critical? And we just need to keep doing the work to figure out what makes that happen. Nonetheless, there is something patterny perhaps about reading too, right? You have to understand grammar, you have to, there's all sorts of maybe things you can see when you think about what letters tend to come after other letters in a word, the structure of a paragraph, or even a page. All of those things seem to also come into play when we're thinking about these links here, but much more needs to be done there. So in conclusion, what we're really seeing is that this pattern to math link seems to be the strongest, which is really quite in line with things that people have purported thus far in the literature. And also in line with the literature, it seems like this really is critical for early life. Even though this link is strong, we still find this really exciting thing that hasn't been answered before, which is that pattern skills are actually important for both math and reading, and really need, there's really a need to do more work to understand that, and perhaps think about how all of these things might grow together over time, which certainly hasn't been answered. Pretty neat. Finally, we also looked, again, like I said, at this age thing, and we're really seeing that there's something about early life that seems to be a critical time for these links to be developing and be as strong as possible. So that really supports that investment theory that I talked about earlier, that when you're really just starting to engage with academic or educational activities or experiencing, these skills really come into play and seem to be super critical for setting the stage and helping to set you up to learn more advanced things later, where these links are still there, but maybe they're not quite as strong. So this is another reason to think about like these early predictors, right? What are the early predictors of achievement and why? How is that happening? And then finally, what we see, and this is really kind of more of a theory question, right? Is that, are we sure that patterning is even patterning? And it seems like it's something. We're not sure exactly what that is. We're trying to define it. And figure out what makes it distinct, but in this approach that we've used, it's clear that there still are significant links between patterning and achievement in math and reading, even after we account for specific cognitive variables, especially nonverbal reasoning. So there's something unique that links patterning to these types of achievement. Okay, for our limitations and our future directions, we still have lots and lots of questions to answer here, and certainly there's some traction being gained in the field in terms of focusing on this, but there's a lot to be done. So we've helped to sort of identify that it seems like patterning is an important antecedent of achievement, but we still don't really know what it is and how it fits into older theories of cognition. If you think about the general model of intelligence proposed by Cattell, I don't know, or other people's, right, from people from the 60s or so, there is no mention of this idea of patterning, but certainly we know that researchers like to sort of reinvent the wheel, and that's the question. Are we looking at something that is maybe already being measured? We think we're starting to answer this. We see some evidence that it is its own unique thing, but really what we need is some other types of studies out there to help us to figure this out. We need some confirmatory factor analyses and other types of analyses that will help us continue answering that question and pinpoint what patterning is, what the mechanism is that underlies its link to achievement. Another thing that can happen now that we've done this first step, which is really look at all this correlational data and say, are these links even there? People are out in the world right now and they're trying to do intervention studies and say, okay, if we can target patterning skills, will we see some traction and some enhancement in early math skills or early reading skills, or will we see that down the line? People have done that work, only a few studies, but now that we've sort of, what we were trying to do was chip away at this a bit and say, okay, well, before we can really say people should go out there and do that, let's make sure these links really exist. So we've done that. So now I call onto all of you and say, I think it would be interesting to do some of this intervention work. although there's some question about that, it's a whole other topic in terms of whether domain general skills transfer. But certainly we can at least do them if some people are interested. And then finally, it's really the biggest call maybe is to really get more data out there. So we know lots of this data really focuses on early childhood, but certainly there can be lots more done looking at how these skills develop over time and getting trajectories of these skills beyond just ages 4 to 6 or even 7 or 9 or something. How are these skills developing in adolescence? How are they developing even in adulthood? And you can be quite creative with how you measure these. So we've done 2 studies with adults, and we gave them these very basic tasks, and we apologized to them in advance and said, we designed these for children. And you might think this is ridiculous that we are giving these to you, but we just are trying to understand like what these tasks, how these tasks work. And so we really need adults to help us out. And using the exact same tasks rather than looking at accuracy, which was always 100%, you look at response time, right? Or you can find creative ways to do it, or we need some new measures and we need people to come up with good measures that are hard, that are even hard for adults. As well as diverse samples and really focusing on different topics of math and reading, as well as cognition. So I am going to wrap up there, and I think I've made my time mark, and I'm very happy about that, because that was my biggest stressor. But before I do, I want to say thank you to my PhD, my postdoc advisor, Emily Fife, our meta-analytic gurus over here who really help with the data side of things, Peng and Wei, and then a graduate student in Emily's lab who helped me with all the tedious coding. So, yeah, thank you guys.